Lesson 97 is about angles and triangles, the Pythagorean theorem, and special right triangles called Pythagorean triples. So we do know that, I think you all know, that the sum of the interior angles of a triangle is 180 degrees. And any triangle that contains a right angle is called a right triangle. So the three parts of a right triangle, and I'm going to show this as a right triangle by putting a square there. This is leg 1. This is leg 2. And this is the hypotenuse. The hypotenuse is always opposite the right angle. Okay? And obviously, these legs are not necessarily named legs 1 and 2, but those are called legs. And this right here, this line, that side there, opposite the right angle, is the hypotenuse. So, the Pythagorean theorem is a squared plus b squared equals c squared. And we have special right triangles that are listed there in your notes. They are Pythagorean triples, and they're useful to memorize because they are always the same. So a 3, 4, 5, that just means that there is, if you have a length here of 3 and a length there of 4, then your hypotenuse will be 5. What if you had this? How could you find x? Well, you could find it using the Pythagorean theorem. Or you could recognize, this is just a multiple of my special right triangle, 3, 4, 5 triangle. All right, everything's multiplied by 2, so x would equal 8. But let's just check it and make sure. So 6 squared, I'm using that for a, plus b squared equals 100. Or 10 squared. I don't know why I didn't just write 36. So 36 plus b squared equals 100. If we subtract 36 from both sides, b squared equals 64. If you take the square root of both sides, you find that b equals 8. Okay, it says use the Pythagorean theorem to find the missing side. So we have, I'll just go ahead and draw that right triangle, sort of. We've got k, we have 5, and we have the square root of 61. All right, well, let's go back to our formula here. A squared plus b squared equals c squared. All right, and we know that this side is c because it's the hypotenuse. All right, the hypotenuse is always c. All right, so we can write out k squared plus 25 equals 61. All right, and I got 61 because square root times itself is going to equal what's under the radical. All right, I could have done another one. I could have written it this way first. K squared plus 5 squared equals the square root of 61 squared. All right, and so we go from that to this. All right, so now if you subtract 25 from both sides, we find that, I'm going to change colors, k squared equals 36. If we take the square root of both sides, we find that k equals 6. All right, let's do another example. Let me just say real quick that you need to memorize the Pythagorean triples I have listed. There are actually more than that. We have 3, 4, 5. We have 5, 12, 13. And 8, 15, 17. All right, so those are the 3 different ones that you need to memorize. These are helpful on standardized testing, and they're good to know. They'll help you on your homework. So if you if you memorize these triples, and then you look for any possible iteration of them, multiple of them, it will really help you. Let's look at that one that says 4, 5, and P. So is that one? It's the third one. It's the last. It's the one on the furthest right, on the top row of your practice problems. All right. So you've got a 4, a 5, and a P. So you want to be careful because the question is this a special right triangle? Does this fit? Does P equal 3? That's what I'm wondering. Well, no, because the hypotenuse is always the longest side. Because the hypotenuse is the c squared. So a squared plus b squared equals c squared, or 16 plus 25 equals c squared. What is 16 plus 25? That's 41. 41 equals c squared. So now we take the square root of both sides. So c equals the square root of 41. And that cannot be simplified. If it could be simplified, we would simplify it. But I just want to point out that sometimes you might think it's a special right triangle, but it's not. Work the rest of those practice problems on your own. Lesson 98 is finding the distance between 2 points and also learning the slope formula. So don't get confused between the slope formula and finding the distance between 2 points. In order to find the distance between 2 points, first thing you want to do is graph the points and draw yourself a right triangle. Okay? And because of the Pythagorean theorem, it's pretty easy to figure out what the distance between this point and that point is, between 4, 2 and -3 and -2. Okay? Because it's not hard to find this distance, this vertical distance, or the horizontal distance. So the distance from really in the y direction, we have up 2 and down 2. So we have these 2 up, we have 2 down. So we know that that distance there is 4. The distance here is our x values. So we have a +4 in that direction and a -3 in that direction. So altogether, this is 7. Once again, we want to think, does this fit with one of our special right triangles? But unfortunately, it doesn't. So we are going to have to figure it out. So a squared plus b squared equals c squared. Okay, and c squared, our hypotenuse, is that distance that we're looking for. So 15, 4, 5, 65 equals c squared. All right, and so what does c equal? Take the square root of both sides, and we find that c equals the square root of 65. Can 65 be broken down? Well, 65 is 5 times 13. So there are no perfect squares within that. So we just leave it as so. All right, the next one, 3, -4, and -5, 2. Let's make go ahead and graph that in your notes. And honestly, it doesn't matter if you make your graph like so. Or if you make it like this. Okay, either way, it's the same. You can do however you want. So for the y's, we can see that our total distance is 6 because we went 2 up and 4 down. So that's 6. And for our x values, it's going to be 5 in the negative direction plus 3 in the positive direction. So that's a total of 8. All right, so does that look like a special right triangle? It looks like a multiple of the 3, 4, 5 triangle, doesn't it? Because 3 times 2 is 6, and 4 times 2 is 8. That means that our hypotenuse is 10. So C equals 10. Now, you could have figured that out using the Pythagorean theorem, and that's totally fine. But you can see how helpful those special right triangles can be. And the other part of this lesson talks about finding slope. So slope, this goes back to our linear equations, y equals mx plus b. Now remember, our slope is that m. So we might have had an equation that was written like this, y equals 3x plus 5. And we could graph that. I may not have left myself enough room here. All right, because I have to go up to 5 because my 5 is my y-intercept. 1, 2, 3, 4, 5. That's where it crosses the y-axis. I better change colors. And then my slope, remember, is rise over run. So I rise 3 and I run 1. Whoops, right about there. Or I can go down 3 and go to the left 1. And that'll help me draw my line. Down 3, over to the left 1. Okay, since I made my y-intercept so high and I didn't draw my... Okay, so this 3 refers to the slope. All right, so as you can see, 3 is a very steep slope. There's going to be times when you're going to be asked to find a slope. You'll be given 2 points, and they'll want you to find the slope. So our formula for that is right here. Slope equals y2 minus y1 over x2 minus x1. So the first example given, the first practice problem given in your notes is find the slope between these 2 points, -3, 4 and 5, -2. And so we can just plug these into the equation. Now, it doesn't matter which one is y2 or y1 or x2 or x1. You just have to be consistent. So I'll just stick with red here. M equals, I'm going to say that this is 0.2 and this is 0.1. Okay, so my y2 is -2 and my y1 is 4. Over my x2 is 5 and my x1 is -3. So 5 minus -3. All right, obviously that becomes a plus. So I end up with -2 minus 4 is -6 over 8. And that can be reduced to -3 over 4. And I'm going to erase this graph because this graph doesn't have anything to do with the slope we just found. All right, because hopefully you remember that when you have a negative slope, what it means is that your line is going to be pointed downhill like this. Okay, so that's what the negative on the slope means. Let's look at the next example. And, oh, it tells us to reverse our points. So now, instead of this being 0.2, this will be 0.1, and this will be 0.2. This is just to show that you'll get the same solution either way. I'm going to do it in black this time. M equals y2, which is 4, minus y1, which is negative 2, over x2, which is negative 3, minus x1, which is 5. So you can see we get 6 over negative 8, which gives us negative 3/4 again. So it really doesn't matter which way you do it. I would like for you guys to finish up those practice problems. There's some for finding slope, and there's some that are finding a distance. Lesson 99 is about uniform motion, unequal distances. I'm going to just write a little 99 up here so we can see that well. This is lesson 99. All right, so on these types of problems, the thing you always want to do first is write your distance formula. Distance equals rate times time. The key to solving these types of problems, in my mind and from what I've seen of students, is to write down what you know. Oftentimes students will just say, I don't have any idea how to attack this problem, and they haven't written anything on their page. So there's something you can do. You can always write the distance formula. Distance equals rate times time. The next thing you can do is write down what you know. So, for example, the first problem says, at 8 p.m., Achilles left camp and headed south at 20 kilometers per hour. Okay, so far we know that Achilles left at 8 p.m. and that his rate was 20 kilometers per hour. All right, so the rate of Achilles equals 20 kilometers per hour. At 10 p.m., Patroclus headed south from the same camp. Patroclus? I'm not really sure. He headed south from the same camp. So if he was 50 kilometers ahead by 3 a.m., what was his speed? Okay, so we know the distance of the guy whose name starts with a P. Okay, and his distance was Achilles' distance plus 50 kilometers. All right, and we know the time at 3 a.m. So this distance reflects a time for Achilles. 8 p.m. until 3 a.m. How long is that? That's 7 hours. And the guy whose name starts with a P, his time is from 10 p.m. to 3 a.m. So his time is only 5 hours. Okay, so we haven't really calculated anything. What we've done is we've taken our information from our problem and simply written it all out. So now is when you have to kind of figure out how you can put all of these things together. And what can I substitute for what? So we're going to kind of focus on this equation here. All right. So we have Achilles R and we have Achilles T. Okay. And we're looking for Patroclus's rate. What was his speed? What was his rate? So we have his time. So we can substitute R sub P T sub P equals R sub A T sub A plus 50. And now let's substitute the things that we know. We don't know RP, of course, but we do know that TP is 5. So 5 RP equals 20 times 7 plus 50. Okay, so 5 RP equals 140 plus 50. 5 RP equals 190. And now divide both sides by 5. And RP equals 38 kilometers per hour. Let's look at the next example. Rachel has a 15-kilometer head start on Charlene. How long will it take Charlene to catch Rachel if Rachel travels at 70 kilometers per hour and Charlene travels at 100 kilometers per hour? So we have two rates. We know something about the distance. Let's think through that. So let's see, Charlene is starting from this point, and Rachel is starting from this point, and there's 15 kilometers here. Okay, because Rachel has a 15-kilometer head start. And the question is, when will Charlene catch up to Rachel? When will their when will essentially their distances be equal? But we have to remember that Charlene's distance is going to equal Rachel's distance plus 15 more. All right, so first thing we're going to write is that distance equals rate times time. Okay. The other thing that we want to write is that Rachel's distance equals Charlene's, actually that's not what I meant to write. Charlene's distance, that wasn't what I meant to write either. Charlene's distance equals Rachel's distance plus 15. Okay, because Charlene's having to travel a whole lot further. All right, we know the two rates, so I'm going to write those down because we want to always write down what we know. So Charlene's rate is 100 kilometers per hour. And Rachel's rate is 70 kilometers per hour. All right, and what we're looking for is time. All right, so it shows that that Rachel started from a different point than Charlene, but their time is starting at the same place. So TR equals TC. There's not going to be a difference in their times, and that way we only have one time to deal with, which is really helpful. So now we can start to substitute. So I'm going to go back to this equation right here and substitute RTs for my Ds. So RC TC equals RR, the rate of Rachel, times the time of Rachel. But since our times are the same, I'm just going to put TC there so that our times are the same. And we really don't even have to have a subscript on our times because our times are the same. So that's really helpful. And we know what our rates are. Whoops, I forgot to put the plus 15. Okay, so we have 100t equals 70t plus 15. All right, if we subtract 70 from both sides, we get 30t equals 15. And divide, we find out that t equals 1/2. And since our rates were in kilometers per hour, that's 1/2 of an hour, or 30 minutes. Let's do one more, and then I'm going to have you guys finish these on your own, and during our Zoom meeting, you can ask me questions if you're not really sure, or we can work through those together, or I can have you guys work through them for your classmates. So Harry and Jeanette jog around a circular track that is 210 meters long, okay? Jeanette's rate is 230 meters per minute. Let's write our D equals RT because that was the rule I gave you. All right, and we know that the rate for Jeanette is 230 meters per minute. And Harry's rate is 200. Okay. The question is, how many minutes will Jeanette be a full lap ahead? All right. Well, we know that D equals RT. And what we're trying to figure out is at what point in time will Jeanette's distance equal Harry's distance plus 210 meters. Because remember, the circular track is 200 meters long. Okay, and at that point, she will have lapped Harry. And so now we can start to substitute the rate of Jeanette times the time. So the question is, how many minutes will Jeanette be a full lap ahead? Rate of Jeanette times the time of Jeanette equals the rate of Harry times the time of Harry plus 210 meters. Okay, and they are running the same amount of time, so the time of Jeanette is equal to the time of Harry. Those are kind of the tricky little things that sometimes it's hard to figure out those parts. But with practice, you'll get better and better at it. So since we know their times are the same, we can just substitute for their rates. So 230t equals 200t plus 210. Subtract 200 from both sides. 200t, not 200. And we get 30t equals 210. Divide both sides by 30. And t equals 7. So it will take 7 minutes for Jeanette to lap poor Harry. So lesson 100. Wow, lesson 100, that seems monumental. It's about place value and rounding numbers. And I'm just going to say that really and truly this should be, in theory, review. If it's not reviewed, that's okay. But there is no reason that you cannot learn this. And if you have failed to learn place value in the past, it is something that you really need to work on. There are a multitude of charts out there you can find online. The main thing to remember is that when you have, and actually they're not even asking you in this lesson, all they're asking you to do is to round. So all you have to be able to do is figure out what the place values are. So for the first one, it says round that number to the nearest 10,000. So I'm going to write the number out. 47, 258, 312. Okay, so here we have our units. These are our thousands. And these are our millions. Okay, so we would just read it as 47,258,312. And, of course, we read the decimal point as and when we go down this way, tenths, hundredths, thousandths. Okay, so we have 65. You just read that as 65, and then you add to the end thousandths. And they want us to round it to the nearest 10,000. Okay, and make sure you're reading closely. Is it 10,000 or thousandths? And this is definitely thousand. So that would be right here. And so what we're going to do is we're going to find that spot, and we're going to check to the right, okay, and that's going to tell us that we're either going to round this to 47,250,000 or 47,260,000. Okay, and what this, I put a check mark above the 8 because that's to the right of the digit we're rounding. So if it's 5 or more, it tells us to round up. So this is what we would round our number to. All right, let's do one more. The next one is to be rounded to the nearest thousandth. So 104.06245345327, and we want to round it to the nearest thousandth. So we reviewed tenths, hundredths, thousandths. So we want to look at the one beside the thousandths, to the right of the thousandths. That's a 4, less than 5. So we keep it as it is, and all of the others just fall away because it's less than 5. This should be a relief to you because it is actually a whole lot easier. Oh, let's do one more actually. Let's do one. The bottom row on the left is a repeating decimal problem, and it says round it, and I give you several different things. 0, 3, 6, 4 is repeating. It says round it to 5 decimal places. Well, I only have 4 shown, but what that line means, of course, is that that's repeating. So I can write it as this, 314.0364364364364. That's the part that's repeating. So writing it out like that will help for what I need to do next. It says round to 5 decimal places. So let's just count. 1, 2, 3, 4, 5. Okay, so then we look to the 6th one. We check that one, and that tells us round up. So our answer for A would be 314.03644. Okay. B is 9 decimal places. So let's erase that little check mark because that doesn't apply anymore. And we want to go 9. So those dots represent 5, 6, 7, 8, 9. So we check this one. And our answer would be this, with the 4 dropping away. And then the next one is to the nearest hundredth. I'm going to let y'all do the nearest hundredth and the nearest 10 on your own, and we will check over that in our Zoom meeting.